Hello children. Now that we have discussed what is uniform motion, what is non-uniform motion, how to calculate speed, let's see some other terms in motion. We have seen that speed is nothing but the distance traveled by an object per unit time. Speed is a scalar quantity which does not give us any information regarding the direction of the object. So to know the exact location of the moving object, we should know the speed as well as direction in which the object is traveling. This gives us another quantity called as velocity. So what is velocity? Velocity of a body is the distance traveled by it per unit time in a given direction, or it can also be defined as velocity of an object is the speed of the object in a specified direction. If you just go back, you remember displacement is nothing but distance traveled in a given direction. So velocity can also be defined as displacement per unit time, which is the same as distance traveled per unit time in a given direction. So the formula of velocity is distance traveled in a given direction by time taken, or displacement by time taken. So how is velocity represented? Velocity is represented by the small letter v. In case you want to differentiate it from speed, it can also be denoted by this arrow mark at the top. So the small letter v represents speed, and v, when you also place an arrow mark showing the direction, it denotes velocity. So now let's define what is uniform velocity. When an object travels, here in this case it's a straight line, when an object travels equal distances in equal intervals of time, then the object moves with uniform velocity, or we say constant velocity. You can see here in a straight road the car is traveling, and every 1 second it is traveling 20 meters. So this vehicle is moving in uniform velocity. So what is non-uniform velocity? When an object is not moving in equal distance in equal intervals of time, or we can say when an object covers unequal distances in equal intervals of time, then the velocity of the object is said to be variable or non-uniform. And even if the speed is constant but the direction keeps on changing, then again we say that the velocity is variable or non-uniform. You can see here the diagram where the vehicle moves in a circular path. So at every instance, if you see, the direction keeps on changing. So here again this is an example of a vehicle moving in with non-uniform velocity. If you remember average speed, how did we calculate average speed? It was the total distance covered by the total time taken. Now we will see how average velocity is calculated. Average velocity is equal to initial velocity plus final velocity by 2. So we are taking the arithmetic mean of initial and final velocity. Initial velocity is represented by the small letter u, and final velocity is represented by v, small letter v. So average velocity is u plus v by 2. And the unit of velocity is the same as speed. It is meter per second. Let us take an example. Suppose a train starts from a station. Initially, if you see, the train is at rest, but after some time slowly its velocity increases, and then finally as it approaches the destination station, its velocity gradually decreases and finally it comes to rest. So if you see here, the velocity of the body was continuously changing. Initially the train was at rest, then slowly the velocity increased, and then when it was nearing the station, the velocity decreased, and then finally it halted. So this is an example of a non-uniform motion, or we can say that the train showed an example of a body moving with a non-uniform velocity. So this change in velocity of an object is called as acceleration. So we can define acceleration as the rate of change of velocity with time, and we can represent it using the formula acceleration equal to change in velocity by time taken. And we already saw that change in velocity is nothing but the final velocity minus the initial velocity. So acceleration is nothing but final velocity minus initial velocity by the time taken. We know that final velocity is represented using v and initial velocity by u and time by t. So acceleration is represented by the symbol small letter a. So a equal to v minus u by t. We know the unit of velocity is meter per second and the unit of time is second. So the unit of acceleration is meter per second or meter per second square. Now we will try to define the terms uniform and non-uniform acceleration. We saw that acceleration is nothing but the change of velocity per unit time. So only if the velocity of an object keeps on changing, that object will have an acceleration. So uniform acceleration is nothing but when the velocity of the body increases by equal amount in equal intervals of time. Let us take an example of a moving vehicle. In case the car covers 25 km in the first 1 hour, then next hour it covers 30 km. Then after that it covers 35 km per hour. So if you see the velocity, it increases by 5 km per hour, or it increases every hour, it increases by 5 km per hour. So in this case we can say that the car is moving with a uniform acceleration. Another example is that of motion of a freely falling body. You can see here the velocity of the ball. You can see here it's an inclined plane. So if a ball is allowed to fall down an inclined plane, the motion of the ball gradually increases as it comes down. So this is also an example of uniform acceleration. So now what is non-uniform acceleration? If the velocity of an object increases by unequal amount in equal intervals of time, it is said to be moving with non-uniform acceleration. Suppose in the first hour the vehicle moves with a speed of 25 km per hour. In the second hour it moves with a speed of 30 km per hour. And in the third hour it reduces the speed by 15 km per hour. Then we call the object to be having non-uniform acceleration. A very good example is movement of vehicle in a crowded road. So as soon as the road is clear, the vehicle will be able to increase its velocity, but whenever there is a crowd or traffic, definitely the velocity reduces. So this can be taken as an example of non-uniform acceleration. Now we will also see what is meant by retardation. When the velocity of the body is changed, we say that it is accelerating. The velocity may increase or decrease. Depending on the increase or decrease of the velocity of a body, we say either the object is accelerating or it is retarding. So if velocity of the body decreases with time, then we call it as retardation. Here the acceleration is negative. So negative acceleration is either termed as retardation or deacceleration. And retardation is again calculated by the formula change in velocity by time taken. And the SI unit is the same, which is meter per second square. An example of retardation, suppose a vehicle is moving with a speed and suddenly brakes are applied and it comes to a stop. So suddenly the velocity reduces, and it is an example of retardation or negative acceleration. I hope these concepts are clear. Keep revising them again and again. Let's try out some numericals and check whether these concepts can be applied there.